Hey everyone, welcome back to the Summer Pi series, and in this video we're finally going to talk about that strange looking activation function, ReLU. ReLU is short for a rectified linear unit. It's linear for all positive outputs and zero for negative outputs. It's a simple function, easy to compute. It follows the idea of activation functions which are inspired by how neurons activate in your brain. But the main motivation for using ReLU is to avoid the vanishing gradient problem. But what is that? Let's look back at gradient descent and backpropagation. We can start thinking a little deeper about what's going on in this process. So when we're updating our weights, we're checking how the weights change with the error. But when we do this, we actually use the concept of the chain rule. What does it do? Well, without the math, just consider it like this. To update the final set of weights, you'll see how the error changes when the final outputs change. But then these outputs are based on those weights. It's this chain that allows you to understand how to change your weights. Then to update the layer of weights before that, you just continue from what you did before. But now you consider that those last set of weights are based on the outputs that came in from the previous set of nodes. And those numbers are based on the weights before that, resulting in the chain that updates those next set of weights. And this process continues. Notice how as you backpropagate to the earlier layers, this expression gets extremely long, and this is where the vanishing gradient comes in. Remember the tangent and sigmoid activations? Notice how the absolute value of these functions are between 0 and 1. So most, if not all of the outputs are going to be decimals. What happens when you multiply these small numbers by each other? They just get smaller and smaller. But then you risk the ability to learn anything more in the earlier layers because the gradients end up becoming so small, and then you continue to multiply by small numbers. They just start to vanish. By using ReLU, we could scale up these numbers to be larger and prevent this while still preserving the idea of activation neurons. And that's really all there is to the strange looking activation function. It has proven itself throughout deep learning research, and it is a trustworthy activation function for most cases. Now that we understand ReLU and mini batches, we'll start to build our CNN in the next video, and I hope to see you there. Peace.